Thank you to all those who've joined us so far. We do still have 2 minutes, so just wanted to thank you all for being here, and we'll get started here in 2 minutes. All right, well, welcome back, everyone. I hope your first session, you learned a lot and have a few things that you're going to take back with you today. It is my honor to introduce to you Santhi Sridharan. Santhi is a seasoned technology leader with deep IT expertise, broad technology knowledge, and a drive for using the power of tech to solve business problems. She currently manages the horizontal platform for Capital One's agent servicing product. In her 20 plus years, she has worked for companies such as Capital One, Circuit City, AIG. She's developed numerous compelling technology strategies while being consistently guided by a belief in building great teams and communities with supporting processes to objectively achieve goals. Santhi, we're excited to hear from you, and I will pass off to you to talk about a checklist for developers.
Thank you, Courtney. Good morning, everyone. How are you all doing? Well, if this was an in-person conference, I can definitely hear a lot of cheers, so I'll take it. And it's my pleasure to be joining you all at this event. I just wanted to, those are my two children. They always make me feel I have to strive to do my best every single day. But my top passion is to develop strong software engineers with delivering, who can deliver top of the class software, and that passion makes me come to work every single day. So I want to share my checklist for delivering maintainable software solutions. In today's world, software teams are expected to deliver features rapidly. Who doesn't know about it? The ever-increasing demand for delivering solutions quickly pushes software developers to deprioritize aspects of maintainability and supportability. These usually go into the backlog as tech debt. In my 20 plus years in tech, I have seen many teams get stuck in this tech debt quicksand, but I have also seen many teams handle maintainability right. So let us look at how development teams can help ensure that the software solutions they deliver not only meet current requirements, but are also maintainable so they don't become irrelevant quickly. Who wants their product to not exist even after they get out of the team or the company, right? So this is a checklist for building such a resilient solution. Before we get into the details, let's look at the definition for maintainability. This is as per ISO standards. In essence, maintainability is a measure of the effectiveness and the efficiency with which a product or system can be modified. And the modification can be to either improve it or correct it or adapt it to changes in environment and in requirements. So in essence, like, if you have a product, it's not a one-time done deal. You're constantly going to have to maintain it. The 5 facets to making a product maintainable are: modularity. The product should be made of modules and components. It shouldn't be a single siloed, lines of code, one big chunk. That doesn't help, because the modularization helps minimize the impact from a change that you will be doing in one part of the code. Next is reusability. The product should compose of components and modules that can be reused and not like recoded every time, because it increases the cost of maintenance. Analyzability. A good product should be analyzable, means you should be able to diagnose the deficiencies and causes of failures, or when you make a change, or in one piece of the code. So you should be able to quickly analyze, not spend days and days inspecting the code to understand what exactly is that product or particular piece of the code is doing. Modifiability. It's not important that you just develop a product, because constant change is the only thing doesn't change. And so you should also be focused on making sure that if you need to modify, that can be done efficiently and effectively with less chances of introducing bugs. Last but not least, a previous speaker in this session spoke about automating testing and emphasized the testing needs. It's a very critical piece. And when I say the testability is a facet of maintainability, you have to understand that just because you write a piece of code doesn't mean that you are going to be able to test. You have to incorporate the pieces in such a way that the code can be tested. So now, understanding those maintainability facets, let's look at what the benefits that we gain from making a software product that is maintainable. Ensuring that your software solution incorporates these maintainable qualities guarantees that you will be able to add new features or fix issues and improve performance without introducing new bugs. Of course, nothing is perfect in this world, and software is definitely, I believe, is illogical. So when I say perfect, I meant 99.99999% perfect. It also helps in increasing the adaptability to changes in the environment. And last but not least, as a team lead, as a development manager, I am always focused in how do I bring new engineers, how do I transition off engineers, so that end of the day, I tell my engineers, your ability or your awesomeness comes when the day you leave the team, nobody sees the impact of you leaving the team, which means you have developed a resilient product, and you have developed a product that anybody following you can take, enhance, and maintain, and you have all the things that you have followed the checklist for them to do so. So moving on to seeing what the real world challenges are in producing maintainable software solutions. Of course, we have a great intent. We understand the benefits, but everything has challenges. That's what makes our job fantastic. So the need for producing maintainable software solutions does not need justification. In a perfect world where all the feature requirements are laid out clearly and the development team gets all the time that they need to deliver, producing a maintainable solution would be a desirable challenge. But in reality, developers are usually delivering under time crunch. The short iterations of the Scrum methodology and the need to produce visible features for the business team and customer can demand a lot of tenacity on the part of the developers to stick to developing a maintainable software. Otherwise, it becomes difficult to hold on to maintainability when delivering a software solution. So I would like to quote a simple example, and anybody can attest to this. How could we say you want to display a list of values? What's the simplest way to do it? The easiest option would be to hard code the list based on current requirements. I have A, B, C, D. So just like produce the list in a list box, but such a solution requires change to the code if we need to add one more value to the list or change, the existing value. And what does that code change mean? We have to add additional tests and, we have to build and deploy. But in contrast, consider creating a database table with a set of options. That is just another option, right? But the impact of a change would be much lower. Of course, you will have to test and deploy, but it is a code change to database, and that may not require a new build and deployment of your application code. However, the upfront cost of developing a new table in the database and managing the asset will take time and resources. And for this reason, it is to go with the hard coding option despite the drawbacks. This creates a tech debt. And I would like to quote one of my senior distinguished engineers, John Bordner, who beautifully said this about tech debt. There's nothing fundamentally wrong with tech debt. Like all debt, it's just borrowing from your future self to make life better today. The problem comes when you have way too much tech debt and can't pay yourself back. Development teams are going to incur tech debt. It's simply a matter of understanding that they have to include the payment schedule in future development plans. This is beautifully said. So nothing is perfect, but it has to be a balance. If it falls on the shoulders of the development team to ensure that the tech debt is kept in check, it becomes necessary to develop guidelines which can help them balance the accumulation of tech debt while estimating time to deliver. So this is a true challenge that we all face in upholding this beautiful intent. And now let's see how we can actually evaluate, or like what are the things that I focus on when I think how I want to develop a solution. In my role as engineering manager at Capital One, I work to impress certain standards on my teams to ensure that we are delivering maintainable software solutions. So without much ado, let's see how to take all these checklist items and help ourselves to make a software product maintainable. The first one is balancing reusability and modularization. Those are the two facets for a maintainable software solution. So designing a maintainable solution calls for a modularized solution with you need to make the components reusable. Targeting highly reusable components and modularization of every single feature will require expert developers. Now, a good intent, and here is the cost. You need experienced developers and expert developers, and it increases the cost. But these aspects will be beneficial in the long run due to the decreased cost of maintenance and also the flexibility to make changes. A good design should strive to balance these aspects against the requirements of the product. And hence, we always try to build large applications on top of good frameworks which actually provides this reusable components and modularized code base. While most of these aspects can be handled by the product leveraging a good framework, every developer still should keep in mind reusability and modularization in the code that they produce. It's not like it's a one-time done deal. You need to think, do I hard code this? Do I use a config file, or do I actually use constants, which is like just in that file? Try to like think in long-term aspects. If I have to make a change, how can I do it? And will this be used in different pieces of the application? Can I modularize it? So the next one is incorporating automated testing. The previous speaker spoke about in length about the benefits and the different types of testing, but I want to high level touch upon the three types of testing. Unit test, and she had a nice pyramid wherein like you have a whole big set of unit tests. And then like the next, like you can have a reduced list of functional tests to test the features. And then you still can get to a smaller set of regression tests, that because not every functionality needs to be tested with every deployment, especially when the software is huge and it has a large set of features that require testing. In such a case, it's always good to have a set of slower, more comprehensive tests that you run to smoke test the application and validate that a new build works. This will save testing time while verifying that the changes didn't break existing functionality in a different piece of the application. While testing might seem like an afterthought, it definitely is not. From a module perspective, from a single file change perspective, unit tests become important. From a feature perspective, functional tests become important. And from a whole application management perspective, regression tests become very, very important. And it is the job of every single developer, every single product owner to demand and identify these tests before you even actually start coding. This also will help you make sure that you have understood the requirements and you can actually zip up the requirements before you start coding. The third item in my checklist is to log meaningful events. This is like something that I preach every single day to my team. All good software systems must have a good logging scheme, and this logging must be done with a purpose. Log with a purpose. That's my mantra. Every log event must be comprehensive, containing meaningful information. Logging needs must be identified along with testing needs at the time of feature grouping. Few examples of motivations for logging can be to capture business metrics, which can be deemed as an application need, capturing user navigation for triaging an issue, capturing application events for monitoring application performance and health. So the motivation of logging must drive the details that go into logging. For example, if a log event is written when a user sees an error message, it is important to log the message holistically. Log the user ID, date, time of error, as well as the details of the system state or data that resulted in the user seeing that error message. It is important to be careful not to store sensitive information in logs or encrypt them if they are needed. In my career, I have to say this. I have seen logs like, I'm here. That is great. But where is the information about who are you, where exactly you are, and why are you there? Without these details, this log event just becomes a ding on the drive space, driving up the cost and frustrating support engineers and your product owners and your tech leads to when you are especially faced with a question. You have to think as a developer. I always tell my team, before you log, just think how you will make use of that log. Otherwise, don't even log. So display meaningful user message. Another one of the pet peeve for me every single day to my designer and my product manager. They want to display meaningful user messages so the users don't get confused, especially like I currently work for agent servicing platform that the application is used by call center agents. And you can see how stressful it must be on the agents if we display confusing messages because they are sitting with our customers on the phone. So it is very important that the messages that my application displays is meaningful, but it must also help the user understand what the issue is, what are they supposed to do with that information. Otherwise, simply saying something went wrong, so sorry, try again in 3 to 4 hours is not gonna cut it. They are going to open an incident ticket to the DevOps team, and what's going to happen? Oh, something went wrong, try again in 3 to 4 hours. We show this message for 2,500 plus conditions and we don't know why the user sees. Okay, incident ticket open, spend hours together understanding where did this message come, try to actually build the sequence. No. If you have to make unique messages and make meaningful messages, and guess what? I will add one more thing to this. Log the message and the metadata when you actually show a message to the user, because I can only think of support, support, support. When the user asks a question because they don't have good training, or because they forgot, users dealing with like 15,000 different scenarios, how do you expect them to remember when they see an error message, why should they see the error message? They might actually misconstrue that the system is not doing what it's supposed to do. When they come to you, your awesomeness in logging should help you to quickly, within like 2 minutes, understand why that user saw that message and provide the details, and not spend like hours together to understand and construct the whole story. That is how I want you to think about displaying meaningful user message, especially when you're dealing with a large user base and a large application. The fifth item, and I come from an application infrastructure monitoring background. I spent a lot of time in Capital One. That's one of my my nice times. So I emphasize application and infrastructure monitoring, because a good monitoring, alerting, and good dashboards is like heaven for having reducing any escalations, having good application that the user feels good, and proactively handling incidents. It doesn't even have to be real incident, even a simple question that the user asks because they don't understand. If you have good monitoring and alerting, you can be unassailable in telling, hey, the system is behaving as designed. Okay, let me see what the confusion is. For this, you need not just infrastructure monitoring, which is basically monitoring, the facets of infrastructure, CPU, memory, network IO, all those things, your instance is up or not, but also application monitoring. And when I talk about application monitoring, I should also emphasize one more thing. It is not enough that you monitor upticks or downticks. You have to monitor both. And what do I mean by that? Suppose imagine you have a very resilient system and you are sized to handle 1,000 users when your peak load is say 200. Well, that is 5 times scaling, but you have enough bandwidth and you have enough budget that you have built 5 times this availability and resiliency. But just imagine all you monitor is like, is my user traffic going up? Okay, you can see when it goes close to 1,000 and you can take actions. But if suppose you don't monitor the downtick, you will not understand if there is any blockage to that application. If there is a network blockage that is not within your application, and your environment, not even within your firewall, but your ISP's firewall. So it is very important that you monitor different aspects and you have good thresholds to not only just find the degradation, or not only just to find any degradation from known issues, but also to understand holistically how your application is performing. After you monitor, the next thing that you have to focus on is setting up alerts. This is not a one-time done deal. That is like a continuous thing. As the system evolves, as the user base evolves, your thresholds changes. So this requires understanding of the application and understanding and trends of different features and traffics in your application. Dashboards are a beautiful, I mean, who doesn't like visual, right? So dashboards are a quick way to actually triage issues. So definitely like testing, like design requirements, identifying logging, identifying application and infrastructure monitoring is one of my major important things, because it's easy for anyone, and these days it's a DevOps team, not just a development team throwing the code to a testing team. So always remember, what you throw, you have to make sure it doesn't come back like a bouncing ball to hit you. Make use of application and infrastructure monitoring. So the next one, maintain documentation. I definitely know every single developer out there is now going to throw brickbat at me and heave a big sigh of relief, but sorry guys. Documentation, 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 and documentation. However you look at it, agile, no agile, you have to have documentation to have an easily maintainable software solution. Documentations are purely things that can be, you can call for 100 documents, 200 documents, but what you need depends on your application. But as a philosophy, I basically look for coding standards so that my code base is consistent irrespective of how many people come in and how many people leave. Contribution guidelines. This is pretty important in this day and age when not a single team sits and like develops code, but many people contribute to code. You need to understand what is it, how can I be a good contributor to some other team's application. Project governance, basically calling out all the ifs and buts and how you manage your project. Feature descriptions, let me talk quickly about this. In today's world, many teams, I think, like still if you're using waterfall, all power to you, absolutely no problem with that. But if you're using agile, please don't get into this quicksand of like leaving your feature details in your Figmas, your design docs, and in Jira stories. Try to have feature description documents. At least for me, as a team lead, I really love that because I don't have to go and investigate code or be at the mercy of my developer. Nobody should be at the mercy of anyone. So maintain documentation. The last thing, after all this checklist items, we do get into the tech debt quicksand. And so what do you have to do as a developer? As a developer, as a product owner, as a team lead, as a director, as a head of engineering, what is it that you have to be focused on? Encourage, demand, and make it easy for the development teams to actually have time to eliminate tech debt. No software can be perfect without tech debt. Anything that you actually delay to either reduce cost or quick to delivery creates a tech debt, definitely. So always try to demand at least 10 to 20% of your work allocation time to eliminate tech debt, and it'll be, you'll be very happy. You'll be you'll be developing a product, and your team will be very happy to support a product because definitely they are not going to get called in the middle of the night. And even if they get called, all they have to do is look at the documentation, look at the log, they know where to look, and boom, the issue is solved. So irrespective of the size of the project, setting up good development practices with the focus on enhancing the maintainability of software solution helps the customers, the business, the development and support teams by reducing time and effort required for supporting and enhancing features. You can refer to my Medium blog post that is published in Capital One's tech site or even Capital One Medium on the same topic. Thank you very much for listening to me and giving me this opportunity. I'll open the floor for Q&A.
Thanks so much, Santhi. That was awesome. Just as a reminder, you can use the Q&A box to ask some questions. And I actually have a bunch of questions coming in, Santhi, and I think this one is our winner of the RVA Tech Earpods. Goes to Carrie Marston. What does the life of a lead dev look like? How do you ensure your developers are producing quality code?
Great question. Okay, lead developer. So you are lead. So it doesn't mean that you are the only one responsible, but I can tell as a lead developer, the focus on these maintainability aspects is an every second job, because during code reviews, starts with feature grooming, starts with continues in code reviews, continues thinking of deployment, continues like when you get a support ticket. So your job as a lead developer, especially if you're only doing 50% coding, to coach to your junior developers, to coach your fellow teammates, make sure the focus on delivery is ensuring all these aspects are actually taken care of.
Great, love that. Our next question, Santhi, is from Jennifer. Do you think that agile sprints are causing maintainability issues? In other words, is the speed to deliver overriding the extra time needed to code for maintainability?
So it is a balance. That's the perfect challenge. Definitely, it is a balance. when you are incorporating maintainability aspects, definitely it is going to take time. Not always, yeah, because you would have a good framework, you would have a good pattern for doing it. And once you get into that pattern, it becomes easy. But as you grow, as you expand, your application expand, as new team members come in, it does take a little bit of like time every time, especially a new team member comes in or you find a new pattern. And that is what I called as tech debt. Because constant delivery results focus is also a key thing. So if you create a tech debt that because of the speed to delivery, try to be very conscientious to demand time, come back and eliminate it. Do not keep accumulating tech debt. So
Great.
there's also another question, how these items save time for developers? Definitely. So as you incorporate and define patterns for these different aspects of maintainability, definitely this saves time for developers, because you know what? When constantly there will be questions from your product manager, and constantly there will be a need for enhancement. Every time there is a question from whichever corner of your user base, going to the code base to actually look at it is not right. Look at your logs, look at dashboards. Those things will be a quick win. So instead of spending even an hour, you can quickly point and even deliver on a self-serve basis these identification criteria to answer those questions. So so developers can focus on what they love most, developing code.
So true. So Santhi, you mentioned documentation and how it's such an important part. We have a question from Lori Walker. Is there one form of documentation you would recommend? We see SharePoint, hard copy, wiki links. What would you recommend?
So that is a highly custom question, I would say. Depends on what your tooling in the enterprise is. So I will just focus on what we do, right? Our code repository is GitHub. So I really love to use the GitHub wiki page to talk about coding standards, contribution guidelines. For the feature documents, I do not overload my code repository, but I do link to Confluence page, because that is our enterprise tooling. So, but definitely as a developer, and for all the developer related documentations, I rely on wiki page. It's like a one-stop shop. You have the code and you have all the facets or the documentations required for how you code, how you contribute, how you accept contributions, how you test everything in wiki page. So
great. Well, Santhi, I just want to take the opportunity to say thank you. I think this was so helpful. I love the idea of a checklist for developers. Hopefully everybody was able to take something away from this presentation. Appreciate your time, and stay with us if you're interested in tuning in for the cybersecurity panel. We will be back at the 25 for this session, or you can join one of the other tracks. We will see you soon.
Yeah, thank you, Courtney, and thank you, RVA Tech community, for this opportunity. Bye.